Hi everyone, this is Aditi Chawla with my teammate Sagarika Nayak, and we'll be giving a brief introduction on Apache Cassandra. So, Apache Cassandra is a post relational database solution which is free, distributed, high performance, scalable, and fault tolerant. Cassandra serves as both a real time data store for transactional applications, as the system of record, and as a read intensive database for business intelligence systems. So the underlying concepts of Cassandra are when you're designing the schema for a relational database, the primary thought on your mind is what's the best way to store this data. But with Cassandra, your dominant concern should be how am I going to query this data? Given Cassandra's data structure, writes are incredibly cheap, but reads are expensive. Since there are no joins in Cassandra, if you need data from more than one table, you're going to have to perform more than one read query. But that's the relational way of doing things. In Cassandra, we prefer denormalization. Denormalization is the practice of preferring to duplicate data in all the places you may need to read it, rather than having a single source of truth that can be found based on ID fields on other objects. The real distinction is how Cassandra stores your data. In the relational world, your data is all stored in rows and columns, making up tables. Your table is rectangular, meaning that every row has the same number of columns, and it has a primary key, which can be one or more columns, and each row can be uniquely identified by the primary key. The database system will do what it can to store the rows of your table contiguously. So scans are efficient, and you can use indexes on your tables to help queries quickly find the data you're looking for. But in Cassandra, you use the partition key very much like how many languages use the key of a hash, making it efficient to read and write data based on that key. A Cassandra table can be visualized more like given below. So the internal data structure of Cassandra looks like this. A map gives efficient key lookup and the stored nature gives efficient scans. In Cassandra, we can use row keys and column keys to do efficient lookups and range scans. The number of column keys is unbounded. In other words, you can have wide rows. A key can itself hold a value as part of the key name. In other words, you can have a valueless column too.
Apache Cassandra was developed at Facebook to power their inbox search featured by Avinash Lakshman, who's one of the authors of Amazon's Dynamo, and Prashant Malik. It was released as an open source project on Google Code in July 2008. In March 2009, it became an Apache incubator project. Cassandra is typically classified as an AP system. The CAP theorem, which is also known as Brewer's theorem, states that it is impossible for a distributed computing system to simultaneously provide all three of the following guarantees, which is C, which stands for consistency, which says all nodes see the same data at the same time. A, which stands for availability, which says a guarantee that every request receives a response about whether it was successful or failed. And P, which stands for partition tolerance, which means the system will continue to operate despite arbitrary messages of loss or a failure of part of the system. According to the theorem, a distributed system cannot satisfy all three of these guarantees at the same time. Cassandra is an AP system, meaning that availability and partition tolerance are generally considered to be more important than consistency in Cassandra. But Cassandra can be tuned with replication factor and consistency level to also meet the C level. The advantages of Cassandra include a lot of benefits. It includes massively scalable architecture, which provides a masterless design where all nodes are the same. It in fact provides operational simplicity and easy scale out. It has an active everywhere design, which means all nodes may be written to and read from. Cassandra gives linear scale performance, that is, the ability to add nodes without going down, and which produces predictable increases in performance. Cassandra also provides continuous availability, which means it offers redundancy of both data and node function. It eliminates single points of failure and provides constant uptime. Cassandra also has transparent fault detection and recovery methods, a flexible and dynamic data model, tunable data consistency, data compression, and its very own CQL, which stands for Cassandra Query Language. There are a few disadvantages too to Cassandra. It has no ad hoc queries. This can lead to storing the data multiple times in different ways to be able to satisfy the requirements of our applications. Cassandra does not have aggregations. Newer versions of Cassandra will have limited support for aggregations with a single partition. This is of very limited use because Cassandra is a key value store doing things like sum, min, max, average, and other aggregations are incredibly resource intensive, if even possible to accomplish. It also has unpredictable performance because it has many different asynchronous jobs and background tasks that are not scheduled by the user. The performance can be unpredictable. This means that you may see performance impacts that may not be related to a query or volume of queries. CQL. Yes, this was also listed as a pro, but because of the fact that CQL is very much like SQL, that is a structured query language, it is easy for someone coming from an SQL background to get confused about what is or is not supported. This means added frustration and costs for developers that do not know Cassandra's limitations. When we talk about functionality across industries, Cassandra is used in Facebook to power inbox search with over 200 nodes deployed. This was abandoned in late 2010 when they built Facebook messaging platform on HBase. Cisco's WebEx uses Cassandra to store user feed and activity in near real time. Netflix uses Cassandra as their backend database for their streaming services. IBM has done research in building a scalable email system based on Cassandra. Talentica Software uses Cassandra as a backend for analytics applications, with a Cassandra cluster of 30 nodes and inserting around 200 gigabytes of data on a daily basis. AppScale uses Cassandra as a backend for Google App Engine applications. These are our references, and we welcome questions and queries from the class. We would be happy to discuss Cassandra in depth when the class meets on Monday. Thank you.